Assalamualaikum and hi everyone, welcome back to my video. I hope you all are getting used to confidence interval. I hope that you guys had done a lot of exercises to practice on the different formulas that you had learned for confidence interval to estimate one population mean and confidence interval to estimate the differences between two population mean for the case of independent samples. In this video, I'm going to introduce to you three different formulas that you can use to estimate the differences between population means for the case of dependent samples. Yes, okay, so this is still chapter 2.3, but we're going to talk about dependent samples. Previously in my class, I explained to you about independent samples. Perhaps maybe we should recall what is an independent samples. Okay, so let's do this. In my previous class, I gave you an example of a cow from breed A and cow from breed B. So if Pak Mail wants to decide or wants to determine which breed produce more milk, okay, so he could collect a sample of cow from breed A. So let's say here he has 5 cows from breed A and 4 cows from breed B. So Pak Mail can collect the data from these samples. So for example, after the data has been collected, perhaps this is the amount of milk produced for the sample breed A and this is the amount of milk produced from sample breed B. So you see here, these two samples were taken from two different groups of cow. Okay, 187 here is from this cow, 148 here is from this cow. As for the sample breed B, the 123 is from this cow, 135 is from this cow. So you see, like, each data were collected from different individual cow. They were collected from two different populations. This is from population breed A, this is from population breed B. So therefore, this is called independent samples, which is two samples taken from two different populations. So in this case, we categorize these samples as independent samples. Okay, clear, kan? So next kita tengok pula, let's take a look at what about dependent samples now. I'm going to still use Pak Mail's situation, okay, Pak Mail's scenario. So he has a farm, he has 230 cows, banyak lembu dia. Okay, so this time Pak Mail, he doesn't want to determine the milk production between two different breeds. Instead, maybe he found out a new diet plan. Okay, a new diet plan that may boost up the milk production. Okay, so that is the scenario here. He wants to try out this new diet plan, but he is not sure whether this diet plan will be good or not. Okay, so the question is, does the new diet plan result in more milk production, or will it reduce the milk production instead? Okay, so what can Pak Mail do to determine this? Okay, so what he can do is, from all the cow that he owns, okay, from the whole population, Pak Mail can select a sample of cow. Okay, maybe he choose lah these 7 selected cows. Okay, cow 1, 2, 3, 4, 5, 6, 7, and then Pak Mail collect the milk production from them. He observe, okay, before he start the diet, he do the data collection. Okay, and then after 1 month of these 7 cows, okay, the 7 cows undergo that diet plan. They follow the diet plan, and then again Pak Mail collect the data after the diet plan. Okay, you get it? So Pak Mail collect data from these 7 cows twice. Once before the new diet, okay, before he start the diet, and second after he starts the diet. Okay, so the diet is only done for these 7 cows because they are under this experiment. Okay, alright, so this data set is taken before the diet and this data set is taken after the diet. But you see, now if you can see here, the first data in the before data set comes from cow 1. The second data in the after data set is also taken from cow number 1 because Pak Mail wants to observe, right, what are the changes after the diet plan. So you see, these two data comes from the same cow, and so is these two data. They also comes from the same cow. These two sets of sample data were taken from the same cow. They were taken from the same population. So in this case, okay, this kind of sample, we call it as dependent samples. Okay, two samples taken from the same subject. Both data collection were done from the same subject. Hence, it means it also comes from the same population. So this is called dependent samples class. This is called dependent samples. So dependent samples need most of the time it is the case when you conduct an experiment lah, okay, pre-test, post-test, before and after an intervention or treatment is done. Okay, so this is dependent samples. The difference between dependent and independent is that in dependent samples, you must remember, both samples were taken from the same population, from the same subject. Okay, so cow number 1, twice, the data were collected twice, before and after, and so is for the other 6 cows. Okay class, so this is called dependent samples, right? Now let's take a look at what are the formulas that Pak Mail can use, okay, to estimate, okay, the differences of the milk production before and after the diet. Okay, he wants to know from this sample, how will the diet result for the whole population? Okay, how will the result be for the whole population? Okay. Okay, so now let's take a look at the 3 formulas that you can use to estimate the differences between the mean for the case of dependent samples. There are 3 different formulas, okay? And if you look at the formulas here, so there are 3. For one is for the condition of sigma square d is known, 2 formulas for the condition where sigma square d is unknown, for the case of sample size greater than 30 and for the case of sample size smaller than 30. And if you look at all these 3 formulas, I think you can see that it is very much similar to the one that you had learned in chapter 2.2. Am I right? Yes. The only difference is that here you need to use x bar d, you need to use sigma d, kat sini SD. So what is this D? Does this notation represent? This notation is the differences between the 2 data sets, okay? So mu D here, okay, mu D is the notation to represent mean difference for population for the case of dependent samples, okay? Mu D is the differences between 2 data sets which is dependent. And then x bar d here is the sample mean of the differences. Sigma d is the population standard deviation of the differences. And SD is the sample standard deviation of the differences. Now, okay, you don't worry, class. I will explain to you about all these new notations, okay, how to calculate x bar d, how to get SD from the question. Okay, I'll show you that later. So right now, let's just focus on the formula. There are basically 3 formulas. Okay, sigma d when the population variance of the difference is known, when the population variance of the difference is unknown for the case of sample size greater than 30, and for the case of sample size less than 30. Okay, now example. Jom, let's get right into the example. Okay class, this example is quite elaborated, but don't worry, I will walk you through it. Okay, so let's read this together. A tire manufacturer wishes to compare the made of thread wear of tires between the new and conventional materials. So basically they have new material of tire and old material of tire. And they want to compare these 2 materials, all right? So Pak Mail just now, he wanted to compare between the before and after diet, right? He wanted to compare the milk production before and after diet. Right now, what they want to do is they want to compare the tread wear of the tires between the new and the old material. So how do they conduct this experiment? Okay, this is how they do it. 1 tire of each type is placed on each front wheel of each of 10 front wheel drive vehicles. So basically there are 10, let's just imagine that they chose 10 identical cars. Okay, they chose 10 identical cars, okay? Maybe macam ni lah, okay? Something like this. So what they do is they put one tire at each front wheel. So the choice as to which type of tire goes on the right wheel and which goes on the left wheel is made with a flip of a coin. Let's just say that this is how they do it, okay? They put the old material tire on the left-hand side of the wheel, of the front wheel, and they put a new material tire on the right hand side of the front wheel. Okay, so let's imagine this is how they conduct the experiment. Imagine that there are 10 such cars. Okay, so after they had already prepared these 10 cars, each car is driven for 40,000 kilometers. Then the tires are removed and the depth of the tread on each is measured. So this is how they done the experiment, okay? They drive the car and then they measure apa ni? They measure the depth of the tread in centimeter. Okay, the results were shown as follows. So you see here, there are two data collection. One data collection from the new material tire from each car, and another data collection is measured from the old material tire from all the 10 cars. So class, remember there are 10 cars and each car has the new and old material. So you see here the first data in the new material data set comes from the first car, and the first data from the old material data set also comes from the first car. This measurement and this measurement were both taken from the same car. Alright, so in other words, these two data sets were collected, okay, were measured from the same car. So there's only one sample in this experiment, which are the 10 cars. So the 10 cars represent one population. So in this case, that's why this data collection, okay, these two samples are considered as dependent samples. Okay, so it's really important that you identify, okay, when you read the question, you need to identify whether the given samples, okay, are independent or is it dependent samples. Now let's move on to read the instruction. What does the question want? You need to calculate a 90% confidence interval for the population mean difference in tread wear between new and old material in a way that takes advantage of the reduces variability produced by the paired design. Hence, give the comment on your answer. So basically, guys, what you need to do here is to calculate a 90% confidence interval for the population mean difference between the new and old materials. Alright, so since we had already identified that this is dependent samples, so you will need to choose the one from here. Okay, we need to decide which of these are we going to use. Which of these are we going to use? So if you look at the question just now, all right, there are, excuse me, we should come to here. Yeah, so this is the case of sigma square d is unknown. There are no population variance given in the question. Nowhere. You can't see it anywhere in the question. There is no population variance given. 40,000 kilometers is just the condition in which they conduct the experiment. For 40,000 kilometers is not your data, alright? This is your data. And then they don't give you any variance value, any population variance or population standard deviation value. So therefore, this is the case of sigma square unknown. Sigma square unknown, right? So for the case of sigma square unknown, and the sample size here is only 10. This is the sample size. Car 1 until car 10. So this is the case of sigma square is unknown and the sample size is less than 30. So you will need to choose the third formula. Okay, x bar d minus d critical value multiply sd divided by square root n, and the same goes to the upper boundary, but you need to do addition instead of subtraction. Okay, very clear. This is the formula. Now, how do we find this x bar d and how do we find this SD? Sample mean difference and sample standard deviation difference. So, for dependent samples, okay, to find the mean and standard deviation, you need to first you need to calculate the differences between these two data sets. Okay, so for an instance, for this example, look at the instruction up here. Okay, they want you to find the confidence interval for the mean difference between new and old materials. So because the question mentioned new and then only they mentioned old material, so we are going to calculate the differences by taking new material minus old material. So which means that each individual data from the new material will minus its pair in the old material. So this data is paired with this data is paired with this data. That's why, dependent samples is sometimes is also called paired data. Dia ada pair kan. Okay, so you subtract the pairs by doing new material minus old material and you will get a new data set. So this is the data of the differences. This new data set that you calculated is the data on the differences between the new and old material. So you look at the calculations here. So for example, in the 8th car, 6.03 minus 6.24, so you will get a negative value because this is bigger than the first one, right? So yeah, even the negative value should be included in your answer. Okay, so if you get negative from the subtraction, still put the negative in your answer. So next, what do you do next? Okay, after you had calculated the differences between new and old material, now you can use these data, okay, these data values, input them into your calculator and then use the statistical features in your calculator to find sample mean and sample standard deviation. So X bar D and SD is actually the sample mean and sample standard deviation of the differences data. Yes, okay, this is how you calculate X bar D and SD from the data. Okay class, macam tu. So now that you have X bar D, you already have SD, and then the confidence level here is 90%. So alpha is 0.1, am I right? Okay, so according to the question, it is T alpha, the critical value is T alpha over 2 nu. So go and find this from your table and you should be able to answer the question already. Okay, so here since the confidence level is 90%, so alpha is 0.1 divided by 2 becomes 0.05. So T 0.059. If you find this value in your T distribution table, you will find 1.8331. Therefore, a 90% confidence interval for the population mean difference for a dependent samples is given by these two values. Okay, 0.1262, 0.3378 centimeter. Remember, this is still about mean, so you must put unit. You must write down the unit of the variable. Okay, class? So I think that's pretty straightforward. There's the one new thing that you learn here is that to find the sample mean and sample standard deviation, you guys need to first calculate the differences between the data set. So this is your new learning point lah, from this video. Then just substitute the value into the formula accordingly. Interpretation, we are 90% confident that the population mean difference in trapware between new and old materials lies within 0.1262 and 0.3378 centimeters. It's as easy as that. The most important thing is, when you read the questions in your test or in your quiz or in your final examination, well, when you're given two sets of data, okay, when you're given two samples, it's really important that you identify whether these two samples, are they independent or are they dependent, so that you will choose the correct for dependent samples and independent samples. Okay, I think in my next video, I'm going to focus on the one-sided lower bound and one-sided upper bound to estimate mu d. Okay, that will be all for this video. Okay class, bye-bye.